talking about how we add and subtract radicals. Last time we learned how to multiply and divide, and we've been simplifying, right? So we're going to take it one step forward, and we're going to go on to adding and subtracting. So first thing I want to look at is a couple of examples that just have to do with adding and subtracting variables, because this has a lot in common with it. What are you giggling about? Nothing? Vadim, wakey, wakey, honey. Sunshine time. Okay, so I've got 9x, or 6x plus 9x equals 5x. Are they like terms? Yes. So can I combine them? Yes. What's 6x plus 9x plus 5x? 20x. Okay. Okay, good. What's 13y minus 6y? 7y. How about 12x minus 8y? Can't do it. Why? Good. So you're going to leave it the way it is. You can't combine them because they're not like terms. Well, when we get into radicals, in order to combine them, in order to add and subtract them, we need something called like radicals. Okay? And when we have like radicals, what they have in common is that radicand. The radicand is what sits underneath the radical, right? So if I have 6 radical 7 minus radical 7, do they have like radicals? Yes. What's the coefficient if nothing's written? Good. 5 radical 7. So what you do is you keep the radical and you subtract the coefficients. Vadim, wakey, wakey, sunshine. No, I'm freezing. What do we need in order to add and subtract radicals? No. You need a like radicand. Very good. So, in order, Mr. Smith, in order to make it a like radical, what does it have to have? The same radicand. Good. Okay, so our steps. Okay, so we have some steps for adding and subtracting radicals. First step, you're going to simplify each of the radicals if you can. Okay, we know how to simplify. We find the factors, we break it down, right? Second step, we can combine like radicals by using distributive property. And third step, indicate the sum or difference of unlike radicals. So let's take a look at how we actually do this. All right, first example, we've got 8 radical 5 plus radical 5 minus 2 radical 5. So can we simplify the radical 5? No. Are they like radicals? Yeah. So can we combine them? What is the coefficient if nothing's written? All right, so we have 8 radical 5 plus 1 radical 5 minus 2 radical 5. What are we going to do? Yeah, how'd you get it? Good, so we have 7 radical 5. You don't do anything with the radicals. You just leave it, okay? All right, so how are we doing, okay? Not hard yet, right? Okay, go to the next page. All right, so go ahead and try number 2 on your own. We'll go over it in a second. All right, so do we have like radicals? Yes, so can we combine the coefficients? Yes. All right, 4 plus 5? Minus 1? So 8 radical 3 is your answer. How many people got that right? Good, good. All right, number 3, 5 plus radical 2. Are those like radicals? Can you simplify either one of them? No. So can I do anything with this? You just leave it be. Okay. All right, number 4, are they like radicals? Can either one of them be simplified? So can I do anything? Let them be. God bless you in advance. Okay, so number 5. Now this one's a little bit different. Are they like radicands? Like radicals? No. Can either one of them be simplified? Yes. Which one can be simplified? The square root of 50. Good. So what you're going to do is you're going to bring down your square root of 2. And you're going to break down the square root of 50. What 2 factors are you going to use? One of them has to be a perfect square, yeah. 25 and 2. Good. So we get the square root of 2 plus the square root of 25 times the square root of 2. Good. All right. Still can't do anything with this radical 2, so we're going to bring it down again. What's the square root of 25? What am I going to do with this? Correct. You keep it in the square root until you take the square root of it.
And you keep the first number?
What first number? Yes, because you can't reduce it.
So every time you keep it, or?
Yep, you bring it down every time because you can't change it.
What if it was like, square?
Well, then we would take the square root of it, just like we did with this. Okay, so we have 1 square root of 2 plus 5 square root of 2. What's it come out to be? 6 square roots of 2. Because remember, the coefficient's 1 if nothing's there. So we got the like radicals, which is what we wanted, with square root of 2, square root of 2. We add the coefficients. Okay, so next one, we got the square root of 80 and the square root of 5. Are they like radicals? No. Can one of them be reduced?
Yes.
Okay, now here's a hint. If the other radical can't be reduced, chances are it's going to share a factor with the one that can. Okay, so we're going to bring down that radical 5 because we're going to keep it. So what I'm saying is, chances are, this is going to be the radical 5 and something else. Okay? Yes, Shannon?
Wouldn't the other one be 4 up there, number 5? If you said you're adding them, like it was like 4, not 3.
You don't add the radicals, you only add the coefficients. That's the rule. Just like we don't add the x's, we just add the numbers in front of the x's. 2x plus 3x is 5x, right? We don't change that piece of it. Yes. Okay, so I'm waiting for your question.
No. What if in the,
Radical.
okay, in the radical, what if there was a 4 and then like what would you do?
If I had this, square root of 4, square root of 2, what's the square root of 4? Because it's a perfect square, right? Is 2 a perfect square?
No.
No, so you have to leave it the square root of 2.
So what if it was like at the last step though? Like there was a 1 in front of it and a 5 in front of it? And then what would you do if they were the same number?
If what wasn't the same number?
I think everybody's lost with these questions.
Try to explain, like.
Because that was just ridiculous. Okay, so we've got the square root of 5. Can't reduce the square root of 5. We've got the square root of 80. We said our hint was they have to match up. We have to have like radicals. So chances are one of the factors is going to be a 5. Shelby, what's the other one? Good, 16. Okay, we get the square root of 16, square root of 5. That's how we broke down 80. And then we bring down our square root of 5. Yes. Sure. 4, yep, because the square root of 16 is, no, the square root of 16 is 4. Okay. Can I do anything with this? Good.
What you have to minus 1.
Minus 1 square root of 5, right?
And it's going to be 3.
Good.
I do. I'm not kidding.
Okay, so number 7. Can these both be simplified?
Yeah.
Okay, I want you to, yes, I want you to break them both down. Okay? Let's go over it. Okay. I've got this, you're going to find out in a minute. I've got the square root of 27 plus the square root of 75. So I have to reduce both of these, right? Which means I have to break them up. And I want one of the radicals to have in common with the other pair. Okay? So how am I going to break up 27? Aaron? Not 2 and 9. 3 and 9. Okay, I'm going to put the perfect square first. Okay? Now I want them to have a radical in common. So Vadim, how am I going to break up 75? 3 and 25. Good. So what's my like radical here? Radical 3. Okay. Now, You don't need a 1. No. Carly, what's the square root of 9? 3. So I've got the square root of 9. I'm going to bring it down. It's going to be 3. Okay? Can I do anything with that radical 3? No, so I leave it with it. Plus, thank you, Shannon. And then I'm going to bring down my radical 3. So now when I combine these, my answer is, Dina? 8 radical 3. How many people got that right? Okay, I want you to try number 8, please. Okay. Dina, how am I going to break down the square root of 8? Good, so 4 and 2. Frank, can I break down the square root of 2? So what am I going to do with it? Just leave it. Bring it down. Mike, what do I do here? First half. Which is? What do I do with that square root of 2? Thank you. Okay, so we're writing everything else the way it was. Brandon, what's 3 times 2, Brandon? 6. Good. So we get 6 radical 2 minus radical 2. Maria, give me the answer, please. 5 square root of 2. Because the coefficient, if it's not written, is 1. How do we do with that one? Okay, I want you to do the next 2. We'll come back together in just a minute. Put your pencils down when you're done so I know you're... Okay, so we've got 2 square roots of 18 and the square root of 50. We want to find the sum. What does sum mean? Addition. Good. So we need to break down the square root of 18, and we need to break down the square root of 50. So please don't yell it out. I will call on you. Mr. Maury, how am I going to break down the square root of 18?
9 and 2.
Good. So I've got 2. I've got the square root of 9, and I've got the square root of 2. Okay? Now, Aaron, how am I going to break down the square root of 50? Good. So square root of 25, square root of 2. Why? Because 9 times 2 is 18, 25 times 2 is 50. That's how we get those numbers. Okay? Carly, what is the square root of 9, Carly?
3.
Okay, Carly needs to be able to do these on her own, okay?
Why do I do that?
No, I want you to be able to do it on your own. Okay, so I took the square root of 9, I made it a 3. The only thing I'm changing is the square root of 9. We bring down the 2, we make the square root of 9 3, and we keep the square root of 2 as the square root of 2 because you cannot simplify the square root of 2. Because there's no factors where the other one is a perfect square that can be reduced. Okay? You can't break it down. Okay, so now I've got the second half. Nick, square root of 25, Nick. And what do I do with that square root of 2, Nick? Thank you very much. Okay, now, Shannon, I've got 2 and 3. How are they connected? What operation? So when you multiply them, you get? And what do I do here? I drop down because you can't simplify it, so you just keep bringing it with you. Plus, you can't do anything with this, so you leave it. You just bring it down. Okay? Tim, 6 square roots of 2 plus 5 square roots of 2. That is your answer. Find the difference of 180 and 72. Find the difference of the square root of 180 and the square root of 2. So difference means what? Subtract. So we got square root of 180 minus the square root of 72. We need to break these down. We're finding the factors. So Vadim, how am I going to break down 180? 2 and 45, neither one are perfect squares. Can you think of any others? 36 and 5. Good. Okay, minus. Now I've got the square root of 72. I need to break that down. Good. Square root of 36, square root of 2. Okay, 36 times 5 is 180, 36 times 2 is 72. That's how we find the factors. All right, now, Shannon, what's the square root of 36? 6. Did you say square root of 6 or did you say 6?
That is 6.
Okay, good. So we have 6. Cameron, can I take the square root of 5? So we just bring it down. Now, Carly, what's the square root of 36?
I just said it.
6. Can we take the square root of 2, Carly? So we just bring it down. Now, Dina, are they like radicals? So can I combine them? This is our answer. Okay, so the homework for tonight is page 625, 1 through 3, 7 through 9, 10 through